Hello everyone, welcome back to Enhanced Automation. In the previous episode, we completed the foundation of artificial intelligence. We understood that what is artificial intelligence, what is machine learning, deep learning, and generative AI. And at the end of that episode, Rahul discovered something very interesting. So, Rahul gave a complete requirement to an AI system, and within a second, the AI generated the test scenarios. Then Rahul asked a very important question. So, question was, how is AI actually doing all this stuff? Does AI know all my requirement? Does AI completely aware about the Selenium code? Does AI knows the Java code? How AI is explaining the API error to me? And how does AI actually understand everything in the same way, just like me? So this is what exactly we are going to understand today. And as you guys already seen in the first episode of this particular series, that our whole course is gonna be divided into a 6 phases, and we have completed phase one, which is AI Foundation, and now we are stepping towards the phase two of our course, which is Generative AI. So, welcome to the phase two of Generative AI, guys. And today we are going to understand one of the most important technology behind the modern generative AI system, which is large language model. In short, we says LLMs. So let's continue the Rahul's story and see what new requirement Rahul gets now. So now Rahul has a new requirement now which says that if the customer is giving a 3-time wrong password while logging into a particular application, the account should be locked for a 30 minutes. And only after the 30 minutes, account should be or customer should be able to log in again. So this is the base requirement Rahul received today. Rahul opens an AI system and enter this particular requirement and says generate the AI generate the test cases for this requirement. So within a few seconds, AI gives him a several scenarios. Now Rahul thinks that that's impressive. Then Rahul tries something new today, and he says that generate the BDD scenarios for this particular test cases. AI generated the BDD scenarios. I hope you guys know about the BDD. BDD is a behavior driven development which follows a Gherkin language. It's a very simple and human readable template which comes in a given when then format. So AI generated the BDD scenarios for the test cases which generated earlier. Now Rahul become more curious and Rahul asking the again next question, which is generate the Selenium automation code. So AI gave the Selenium automation code. Now Rahul is becoming more interesting to know whether AI will give me the Playwright script for the same. So Rahul giving a prompt saying like generate the same test using the Playwright. And again, AI did a good job and provided a complete Playwright code for the test cases which is being generated for this requirement. Now, Rahul becomes very curious and Rahul having a lot of question in the mind because Rahul understand the Java, Rahul understand the Selenium, you guys or Rahul understand the Playwright, but how does AI system know all of them? Does somebody have a huge database behind the scene and somewhere which is containing all this every possible questions answer and AI going there and fetch and giving us in a response? Is it the case? No, right? So when Rahul asks a question, does AI simply search that database and return the answer? The answer should be here, no, it is not the case. And to understand what is actually happening, we need to understand the logic behind the scene, and that logic comes with a large language model. So, what is LLM? LLM stands for Large Language Model. Let's break that name into a three simple word. First is large, then language, then models. Okay, so let's start understanding all these three different concepts, what is large, what is language, what is model. So we will start with language. This is a very simple model. Language means to say the model which are designed to work with the different kind of languages and structured representation of a code. So for example, this model will be processing the things like English, Java, Python, and different kind of languages and many other form of text. Now, the next word is model. So model is basically a system that has learned patterns from the data. So model is pretty much similar to a machine learning. I hope you guys remember the machine learning from episode 2, right? We said in the machine learning part that machine learning learns pattern from the examples. So here LLM also learns the patterns, but it learns incredibly complex pattern across the huge amount of text and code. And finally, we have the next word, which is large. So why large? Because modern large language models can contain a huge number of parameters and are trained using very large database and significant computing resources. So in simple term, if we try to define this LLM model, so definition would come as across: an LLM is a large AI model trained to learn patterns in language and generate useful output based on those patterns. But that still does not explain, Rahul, that how requirement becomes test cases. We are simply giving a requirement and how it is becoming a test cases, because okay, it is learning from the different languages, it is learning the pattern, it is having a huge number of parameters, but how those requirement is becoming the test cases? So that is still pending. So let's go one more step deeper to understand how those are actually becoming a test cases and how those tasks are being done in the AI. So imagine Rahul is training a new QA engineer which names Sam. Okay, Sam has just started his career. On day one, Sam knows very little things about the Rahul project. Okay, so Rahul starts giving him information. He gives him a testing document. He gives him automation examples. He gives him a API documentation, programming examples, reports, and technical articles, and many other learning resources. So Sam keeps on reading and reading and reading, and over the time, what start? Sam start noticing some pattern. He learned that if I am using driver.find element with just Selenium snippet, there will be a some locator to find that element. He learned that in the BDD, if I'm using given, which is often followed by a when and which is often followed by a then, he learned that we have a HTTP status code 404, which means that it is related to a resource which is not being found. So he learned that when someone says generate a negative login scenario, they probably expect a scenario involving a wrong password, invalid credentials, and all those things. So during the training, the modern learn statically relationship and pattern the same way Sam started learning. So now comes one of the most important concept in the entire episode. An LLM generates a text largely by predicting what should come next. Let's take a simple sentence. I say the sun rises in the, so you will say east, right? Why? Because you have seen and learned that pattern many times. Now imagine HTTP status code 404 means you might be predicting it is not found. Now, if I'll talk about the Selenium, the WebDriver is used to, then you will say control or interact with the browser. So this is the basic idea behind the language model. You may be predicting something related to controlling and something which is already we learned by a pattern. So the model looks at the context it has received and predict a likely next piece of the text, then another, and this process continues. But there is something important here. What is that? The model does not process the text exactly as complete word the way we normally think about them. It is not the case. It works with something called token. Okay. So what is token now? Let's say Rahul enters a one requirement or one prompt which says that generate a login test. Okay. So in this particular line, generate login test cases. We see four normal English word here, but an LLM processes text as smaller units called tokens. A token can be a complete word, a part of word, or punctuation, or another piece of text. For example, something like this automation testing. So might be represent as a multiple tokens depending on the tokenizer used by the model. So when Rahul sends a prompt, the text is first converted into a tokens. Tokens matter because they affect the things like how much information a model can process or how long a response can be. And when using APIs, often how usage is measured. So these all terminologies will be handled by token. Now, Rahul is having a huge requirement now. Rahul learn about the token. He becomes a very confident now. And then Rahul takes a 200 page of requirement documents, which is having a API document, previous test cases, architectural note, and several logs. And he tries to provide everything at once. And now he discover another important concept, which is context window. So what is context window? So imagine Rahul has a text. On the DEX, he can keep a requirement document, some API notes, some test cases, and few logs. As long as the useful information fits on the DEX, Rahul try to keep it, and Rahul can work on with it. But the desk has a limited size, right? An LLM also has a limit. How much information it can consider in a single context. That's a context limit we have, and that is commonly called context window. Now, different model can support different size of context, and a context is extremely important for QA engineers. How it is important? Let's see. Because just imagine if you ask generate the test case, AI asks internally test case for what? If you provide only one line of requirement, AI has a limited context, right? But if you provide a requirement, acceptance criteria, business rule, API contract, existing behavior, so now the model has much more better context to work with. So remember, the better the context often lead to a better output. But context is not the same as permanent knowledge. If you are providing everything at one context or everything at a one prompt, it does not mean that AI will be keeping it as a permanent knowledge and will be giving you answer all the time from that particular knowledge. That is a different concept, and we will understand that difference later when we will reach to a RAG, which will be treated as a permanent knowledge. But AI here, the context window is not a permanent knowledge. Just remember this part. Now Rahul makes a one mistake. Okay, generate the test cases for our company's internal checkout V3 API. But Rahul never provided any documentation about the checkout V3 workflow. The AI still generate an answer, and the answers looks amazing. That answer is having the headers, we have the payload, we have the endpoint, we have the expected result, and everything looks professional. But Rahul think, wow, it knows our internal API as well, but when Rahul checks the actual API documentation and realizes half of the information was incorrect. Even the some endpoint which came in the response which was not even exist. What happened? What happened to AI now? Why the wrong information is coming? This brings us to one of the biggest problem in the generative AI, which is hallucination. What is AI hallucination? If someone asks you, so in the simple term, you can say an AI hallucination happens when a generative AI system produces the information that sounds reasonable, that sounds confident, that looks perfect, but it is incorrect, or it is unsupported, or it is fabricated. Why can this happen? Remember what we just learned. An LLM generates a output based on the pattern and context, right? It is trying to produce a plausible continuation. It is not automatically checking your company's real database or internal API documentation. So, if important information is missing, the model may still generate something that looks reasonable or that looks matching. So for QA engineer, this is extremely important because imagine if AI generates a wrong test case for you, if AI generates a wrong API endpoint, if AI write a wrong assertion or even a wrong security recommendation, and because the answers look professional, because the test case look very structured, because the API endpoint looks similar to your all API endpoints, it does not mean that we can directly trust the AI response. That can create a serious problem for you guys. So, whenever we use the generative AI, generated the response does not mean that it is verified. As a QA engineer, our responsibility is to validate the output which is generated from AI. Now, the Rahul asked the same question that give me 5 scenarios for a login page. He gets a 5 scenario. Then he start a new interaction and asks the same question again to AI. This time the answer is slightly different. Now, again, he is starting a new conversation with the AI and asking the same question. Now, the answer is again slightly different. Now, Rahul thinks, wait, what is happening here? When I am asking for the first time, I am getting something different. When I am asking for the second time, I am getting something different response. When I am asking for the third time, why my answer is slightly different all the times? If the question is same, why answer is not exactly the same here? This is creating a very big doubt in Rahul's mind. And this takes us to another concept you may be hearing when you are working with the language model, that temperature. So, what is temperature, guys? Let's understand the temperature in a simple way. Imagine if Rahul asks, give me a name for my new automation framework. There could be a many reasonable answers. If we want the model to be more predictable and conservative, we generally use this setting that favor the most likely outputs. If we want more variety or creativity, we can allow more variation in generation. In an LLM system, temperature is one setting which is used to influence this randomness. So by the time I hope you guys understood what is the temperature is. The one concept which can make a difference in the response of AI is temperature. A lower temperature generally makes the output more predictable. A higher temperature generally allows more variation. So the more number of temperature you will be giving in a AI settings, the more variations, more creativity, and more diverse idea you will be seeing in the AI response. So for QA works, this can matter a lot. Suppose you are generating a structured AI assertions. You may prefer more consistent output, right? But suppose if you are brainstorming the unusual exploratory testing, in this exploratory testing, you want a more variation because the more the variation, the more different scenarios and the more different ways to check your application. So, one important point here, not every AI application gives user direct control over the temperature. Not all the time or all the application you guys can go into the settings and change the AI temperature. If you will be doing that, then your chat gpt for someone will be giving a different answer because you have set the temperature in a different way, you will be seeing a different answers. So model behavior can depend on more than this one setting. It is not about only changing the temperature will be giving you that different kind of responses, but you should understand the concept because you will see it when we later work with the AI modules and APIs. So now let's put all the flows together and try to understand what Rahul's learned till now. Okay. So Rahul asks that how can AI generate test case from my requirement? At a simplified level, this is what happens, right? So Rahul writes a prompt which says generate a negative test cases for this login requirement. Now what will happen? Firstly, as we know, we learned the thing which is token. So the prompt will be divided in a very short units. That unit is called token. So the input is converted into a token. So we are from the first point, which is prompt, moving to a second point, which is tokens. Now the input which we gave or prompt which we gave is broken into a model units, a small units. Now the next is the model processes those tokens and make it together a available context for a particular requirement. So prompt is dividing into a tokens and then token is creating a requirement now, and based on those pattern learned during the training, model will try to predict the likely output tokens. This model LLM will try to predict based on this context and based on this token, then what should be the output of this prompt. So one token leads to another and then another, and until finally Rahul sees a complete response, it will keep on going the same. So something like if you are asking for an invalid password, your test case 2 is empty username, your test case 3 is logged user, and so on. So the AI did not simply search a database which contains all these test cases or maybe having a name like Rahul's login test case. It generated the response based on the learn pattern and context Rahul provided. That distinction is very important. So the next comes is there is another confusion we should clear. Rahul asks, when I give my requirement to an AI, am I training a model? When I am giving my requirement to an AI, am I training a model? No, right? These are different concepts. Training is the process of model to build that or to update the model's learned parameters from the data side. Your current prompt is normally a input which you are providing to an already trained modules. So based on your input, you will be getting the response. But it is not like if you are giving an input that will be considered as a knowledge base for your model. No, a simple way to remember this is training is like preparing a new QA engineer just like Sam. is Sam will be spending a month to learn the Java, Selenium, APIs, SQL, testing concept. That knowledge becomes a part of his skill set, right? Now managers give him a one requirement. That requirement is not his entire training. That requirement is a task. So here, if we are giving up one task or one prompt, it is just a to do work for the AI assistant. It is not a knowledge base. So the current context he used to perform the today's task is prompt, and the learning which he learned from months to with the hard work is the model training. So similarly, model training creates the model and your prompt gives the trained model a context for the current request. So what does this mean for a QA engineer? Now we can all connect all of this concept to our daily work. If AI gives you a poor test case, it means that maybe your context was poor. If AI invents something from your project specific information, which means that you may ask something which was not present in the available context. If AI gives you a different answer, which means that a generation can involve the probabilistic choice. If you are giving a huge document and AI is not handling it as per your expectation, which means that the context limit or retrieval strategy is reached here. If you are giving a unclear prompt, which means that the model has to make more assumption. So if the model will be making a more assumption, this will lead us to a something important, which is the quality of your instructions matter. How much good quality of instructions you will give to the AI, that much good quality of response you will be getting from your assistant or your AI. So let's see what Rahul was doing until now. Rahul is simply writing, give me a test cases. It is very too little context, right? Right? So what is missing here? The missing thing is what kind of role, what is context, what is task, what is constraint, what is expected outcomes, or what is output you want, or what are the examples I need to check. So this all thing were missing. So Rahul is simply gives a request or prompt which says give me a test case. So AI generates something and then Rahul complains. These are very basics. But think about it. Rahul never told the AI what application he is testing, what the requirement is, what kind of testing he want, what the format he expect. So imagine Rahul gives the same instruction to a new QA engineer, Sam, give me test case. The engineer would ask, for what? So sometimes the problem is not the AI. The problem is the instructions we gave it. And this is where our next major topics begin, which is prompt engineering. Before we finish, let's quickly recap what Rahul and we learned today. So we learned about the generative AI. So AI generate a new content such as text, code, image, audio, and more, right? And then we learn about the LLMs. So LLM stand for the large language model, and it learn from the complex pattern and huge amount of data. So it can generate a language and it can generate a code. Then we learn about the tokens. So token is a unit of text that language model processes. Then we learn about the context window. So context window is the amount of information the model can work with in the current window. Okay. And then we learn about the temperature. So temperature is one mechanism that can influence how predictable and varied generated output is. And then we learn about the hallucination. The hallucination is when AI generates the information that looks believable that looks extremely perfect, but it is incorrect. So most importantly, an LLM does not simply behave like your Google or just behave like your search engine that retrieve stored data, but the LLM generates output based on the learned pattern and the context available to it. So now Rahul understands what is happening behind the scene, but he still has one problem. Sometimes he gets an amazing answer, and sometimes the answer is completely useless. So why it is happening? It is happening because of the bad prompt. If we are giving a bad prompt, the answer is different. If Rahul is giving a good prompt, which consists a role, context, task, constraint, format, Rahul will be getting a completely different quality of output. So what changed here? The prompt. And that's exactly what we are going to learn in the next episode. In the episode 4, we will learn prompt engineering for QA engineers. But we are not going to learn it only through definition. Rahul will take one real testing requirement. We will start with a very bad prompt and then we will improve it step by step, and you will see how the quality of AI output change at every step. So if you are following this complete AI for QA engineer 0 to agentic AI series, subscribe to In Hand Automation and continue with us. I'll see you in episode 4. Thank you for watching. Till the time, keep learning, keep automating. I'll see you in episode 4. Thank you.